Hey, it's James from Finney Electrical. On today's video, we're testing these two houses. Let's get into this. Right then, so we've got this lovely property to test then. There's a little one behind me then. So apparently it's got the same incoming supply and basically it's paying one standing charge apparently at both buildings, which is fine because it's mostly gas, the appliances and that, I think he said. But yeah, this is what we've got to do. Yeah, it's got a lovely view. Look at that. I think he's going to be renting this out. Look at that, that's lovely that, isn't it? Nice and peace and tranquil. Now I'm going to be honest, I wasn't going to film this video and then, yeah, it's a bit of a, yeah, it's not good. Don't know what to say. Basically I had this Polish guy, who was a very confident young lad, he said, come and wire everything up. Now, at first looks, he's got a dual acid fuse bar, nothing's labelled up, but you can get that, but then everything will be okay. But nothing's labelled up. Fairly neat and tidy, yeah, not too bad. Comes in, all tails, earthing, looks legit, yeah. Wow. So yeah, I'm walking around with a fella and he goes, oh yeah, I'll show you the meter outside. And that's when things start to go south a little bit. So here we go, that's the pylon. Cable comes off that, underground and into your cabinet. So let's just whip this little guy open. And you think, right, let's have a look, let's assess this. Right, so the cable comes in, 3 metre, comes into here. Oh, what is this? Look at that, so they've got an armoured cable and all this is singles, the singles cords. That has to be double insulated. I know there's bits poking out there, that's not good either, but these have like the copper, a sheath, or like insulation, then a sheath, and that's just bare, so that's not good at all, is it? And that is not earth, as I've just found out. Right, it's starting to rain. But yeah, mistake number 1, straight away. And I'm thinking, right, well, all we have to do is just basically gland that earth it, and then stick it in a box, and then some tails out of the box to feed it, and then that's job scudded. But then I saw next door, so you got the armoured cable, it's just kind of in the gutter, and then it just goes, loops across here. And it's not really anchored. You're supposed to have like maybe a concertina wire to kind of support it across that, but it's just kind of dangling across the 2 bits. So for me, that's a big enough distance where this would need its own earthing system. So obviously you'd take the line and neutral, and then you'd put a TT and you put an earth spike in and give it its own earthing system for this building. Because I think there'd be a bigger potential between the earth over there and earth over there. So I know you have to do that for like even garages that are like 5 metres away or 10 metres away, but so that's that. But yeah, coming into here, look at this. This is shocking. This is shocking. Look at that, I'll have to get the torch on. Look at that, so the cable just comes off and it's just shoved in the wall. The loose cables come out and just go into here. Why? And that's not even the worst bit. Look at this. Watch it. Get my torch on. The full thing is removable. It's not even fixed. It's just, it was just nicely just sat on top of there. Big old throat side, you can get your finger in. Oh, it's just a sham, isn't it? My goodness. This fuse bar's not even wired correctly. What you're supposed to do is with these, you're supposed to take that link out. Take that link out, have this as your neutral bar, and then these, obviously these circuits here. That is made a right little sham of this. My goodness. So apparently the guy's gone back to Poland, so he's not going to get him back and get him to fix it. So it looks like I'm going to have to be the bearer of bad news and say, look, it's a right rubbish installation, should we say. So yeah, if these got slightly cut into it, that's your live cable. He's going to get a shock straight away. With this, if you cut into that, you then through that sheathing and then you to this layer, you see, so you got a bit more basic protection, but that's awful, isn't it? Phew, miserable day.
He's spitting, everybody in!
A guy that doesn't have a clue what he's doing, it's working.
Nice seeing yourself!
So apparently the guy's had to go himself as well, so he's put this box in, it's not the last day thing, come off something, and then put a cracked socket in there and a cracked socket in there. So that's going to be flagged on report. So annoying coming across rubbish. I get it daily. Anyway, let's get on with the video then. So we'll show you how to do a radial test, we'll show you how to do a ring test, and any more dodges we'll highlight them. Straight away then, we've got a socket here that is missing a screw, so it's hanging off. You get your fingers there, get a shock. There's your first little dodgy. Just got to do a few little visual checks on the sockets then, so just make sure everything's terminated properly, it's wired correctly. So obviously they've gone to the back box and then the earth leads to the front, which is a weird way of doing it, but it still works. So what we'll do, we'll test this circuit here then. We'll bob them off, and what we'll do is do a ring test. So basically the sockets are wired from the fuse board to every socket and back. So essentially you've got a live earth neutral here, live earth neutral there. So you should have a live continuity, which basically means one thing's connected to another all the way around. So we're measuring the resistance of that, resistance of line, earth and neutral. So they're called end-to-end tests. And then what we do is bang that in on here where it says ring final. There'll be little R1, little R1, yeah, little RN and little R2. And then we'll move on to the next test. There we go, that's what this test looks like. So we've got the line out, neutral out, earth out. So you get your crocodile clips on, bang it on continuity, press test, 0.17. And then what we do is bang it on neutral then, and we should be getting roughly 0.17 again, just because well, it's the same size cable, it's 2.5 cable. It's 0.20, so there'll be a loose connection somewhere on the neutral, but it's not massively. If it was 0.1 difference and we'd look into it, because it's only like 0.03 difference, it's not the end of the world. It could be me clamping on them. If I don't press it or it doesn't get as good connection, you're going to get a worse reading, aren't you? And then 0.29, so we're just going to wrap them in there. So what we're going to do next is called the crossover test, or the ring test. So we're going to take basically we need to make sure everything's got an earth, or an earth fault path, so anything metal is earth, like sockets. So you got line and earth this side, line and earth that side, so you get the line to the earth on the other side, and the earth of this side to the line of that side, and then it creates a big figure of 8 loop. So we should be getting the same reading roughly, within like 0.05 on every socket. And if it's way higher, then there's either some dodgy connections or it's a spur off a spur off a spur. Yeah, there we go. So we'll cut this up. So easiest ways to find your cables is just to give it a little move like that, and you can see which one's moving now, and you know which one's connected on. So now we'll go around then. So that's connected up. It's a 0.27. You test both sides. You can't have it where like one side's not even got an earth. It's just knackered within. You see the difference though, 0.04 difference there. So you remember the highest the reading and go around and count up your number of points as well. So whilst you're bobbing around, you're also unplugging stuff plugged in, because the next test we're going to do is insulation resistance, and we want to disconnect all the loads, so we can kind of test between line and neutral, so if we can. So there we go, so the last one then, 0.12, so really low. Next one. There we go, so the highest was 0.27, so that's the one we're going to write down. Right, so crocodile clips are back on, it's on insulation resistance. I'm just going to test, then we go greater than 500 meg. So that's the line to earth. That is can't speak, neutral to earth, and then what we'll do is just do line to neutral. With everything unplugged, you should get greater than 500, or basically anything over 1 or 2 meg, it won't blow the acid or anything like that. It's still, that's a bad rating, but yeah, so depending on the reading you get, depends what you need to do on that scenario or how you advise. So if it's getting down less than 10, you'd be like, right, if you're going to be selling this in the next few years, then you could rewire it or whatever, if you think it'll add value, or you could just leave it for the next person who buys a house, if they're redoing it anyway, to rewire it. But yeah, if they're going to be keeping it for years and years and years, then they need to be looking at getting a rewire. But anything over like, I don't know, 10, 20, 30, whatever meg, it's good. If it's in the hundreds, like over 100 meg, then you're like, yeah, you're fine for a while. So you just got advice from there. Like I've had it like in the cabling being installed in the 80s. I've been to one property and it's the cable itself has degraded that much. It's just blown to itself, and that was the reason why it was blowing, and that was the fault. And I've been to other places where it's been in a lot longer, and we're getting readings that are greater than 500. So it's all about the conditions that the cable's sitting in the walls as well. So if it's damp, it's going to like degrade quicker. But if it's in a nice dry condition, then it's going to be fine. Yeah, so everything's tested out perfect in this, to be fair. So not too bad. So there's what is it? This here is a bit sketchy, so this has got to get sorted. That's about it really. Everything else is alright. This end, that house looks a bit shoddy. Now apparently another guy did that house, but the other guy that did this house should have picked that up, so dodgy. Right then, so what we're gonna do is finish the test then. So I've just got the lighting to finish off. I'll just pull down a down light, and look, every job, every job, nobody can do a down light properly. This guy has, look at that. Perfect. So, yeah, he's done a good job. So we'll finish off testing the lights, and then we're going to move over to the nightmare house. We might call this the nightmare house. Right, that's this tested and labelled up then. There we go, so on to the next one. We've got these next defects then, so we've got a little hole in there then. Little hole in top, hole in there, that's got no earth, it's all burnt out. So those will need replacing really, if he wants to keep those. But yeah, we're going to move on to the house next. The dreaded house. Right, so we're back over here now. So, yeah, the dreaded fuse board. I think one of the observations is definitely that it's not even fixed. Look at it, it's just floating. It's just sat on top of this one. So, what we'll have to do, well, that's our observation as well. So obviously, I think there's a bit of cable. I don't know. What we'll have to do is try and pull it through. I don't know, bend him up and get a box on up here maybe, or do something on the outside and send some tails through and extend, what is it, 10 mil? It's 10 mil that, I think. Something shocking, isn't it? So it is down rating for one thing, because 10 mil can take like, I think it's just over 50 amp, and at the moment it's protected by 100 amp, so it could be running at 60, 70, 80 amp and it'll just set on fire. So, yeah. Anyway, one of the tests then is called a ZE test. So just set it on, we'll put it on the high current. It's just line and earth. So we're going to disconnect any parallel paths, bang him on there, bang him on earth, bang him on line, press test. Error 4. Great. There we go. So that's that. And then what you have to do is then connect all your loads back in and get a test, and that's your PFC test. So next we're going to do the RCD test. So we're going to make sure that these RCDs are working. So what we're going to do is bang on live and neutral of the outgoing of the RCD. So you can either do it, take this buzz back off and do it here, or we can do it on the neutral bar and one of the MCVs and earth. So we'll do that. It'll basically test at 1 times the operating current, which is 30 milliamps. It'll trip twice on, it basically tests at 0 of the cycle and 180 degree of the cycle. Imagine like a 360. So, and then, yeah, it'll test it 5 times. So it'll test 5 times 30 milliamps and get a reading as well. So just going to make sure that these are working correctly, and then the other test is basically just a functional test, make sure that these trip properly. So we got the results for that then. So for 5 times it's 10.6 is the highest on 0 of the cycle, and then for 1 times the highest was 33.5. You've noticed we've selected the AC one. So there's also, you can also select DC, a type A RCD which allows DC current. So basically if there's loads of LED stuff going on, it'll blind that AC. But on this house there's not a lot of DC stuff going on, so we're good. So it can stay as a type AC RCD. So for that, if you're getting readings higher than 200 milliseconds for 1 times it fails, and anything over 40 milliseconds for 5 times it fails. I'd have to think then. Right, next little dodgy then. So, remember the ring test, you're supposed to get end to end. Fast test, and zilcho. And you test neutral, and you get 0.40. And then you test earth, and you get zilcho.
There's nothing, nada, zip.
Basically, it's put on a 32 amp breaker. If it was a ring, that'd be fine. But as a radial, I think max is like 27 amps, something like that. So if you're running about 30 amps, the line cable will start to melt essentially because it just can't hack it, because it doesn't go all the way around, it doesn't share the load. So yeah, so we're gonna either have to dive into the circuit and find that, but we'll do that another day. So it'll be a loose connection probably, because the neutral's there. So it's probably in the back of one of the sockets. It's most likely with the kitchen, it's like the extractor fan. It's a little fuse spur that people find it hard to get in generally, I've found over the years. But yeah, so it's either that or we just downrate it to a 20 or 25, and then that'll be good. So I'm just testing the, what do you call it, the underfloor heatings, because they're on the off-peak supply. Now it is off-peak, so I've just come up with this unconventional way. You probably shouldn't do it, to be fair, but I've got my volt pen in there. I need to identify what it is. It could be one of 8 of these circuits. So I'll just split this ring, and then what you could do is just wire it in. I'm just gonna turn it on, and then when I tap it onto there we go, it's that one. And then turn it up again. So yeah, it's just a quick way. So I've got an audible cue, because it's only me by myself today, so I can just put my volt pen on and just go boop, 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 and then the one that goes beep, if I can hear it, then it is that one. So it just speed things up a heck of a lot. If not, literally, I'd have to connect line to earth for that one, and then go around all of them, all 8 of them, unscrew it, try and find it, and go, oh, it's that one, and then go for the next one, next one. So this is a lot quicker way, even though it's a bit, well, I'm an electrician, so I think I can do it. I think it goes by the regs. But yeah, it's obviously just working live, but this whole thing's live, and you don't touch that, do you, and lick it and that, so I think it's good to go. Yeah, that's everything tested then. So we've got the Dodgy, to recap, we've got the Dodgy cable in, so from the meter, the cable all the way along to that house. It's an armoured cable, the earthing's not braided, it's not fused down, it's a 10mm cable actually, so it's currently fused by 100 amp, so there could be, I don't know, 90 amp running through that, 80 amp, whatever, and that cable will set on fire, so that's not good, is it? So that's that. What else we got? I think this house was pretty good, to be fair. So whoever wired this, I think it's the Polish guy who wired it, and some other dudes wired that one, and that's shocking, but this one's alright, so this is not too bad. So all the defects then is just when that lad's done his own fuse board, he's got holes in there, that socket's all burnt out, and I think it's wired wrong, and that's all cracked as well, so I'm going to swap them over and fill all the holes for that, gland it off properly. So that'll be that fixed. What else? House, no, battery went. Right, so as far as the house then, that is wired in outdoor cable, that little link coming out, so I'll have to move that junction box higher up and then re-terminate that, get that clipped. What else with that fuse board, crikey. It's just hanging off, it's waggling and waggling. So that's awful, so I have to get that fixed back. Right, both batteries are dead apparently. I'm plugged in. Right, then what else further then? So defects, so yeah, that fuse board needs fixing back properly, and then the cable that comes through, will have to go into like an adaptable box, through crimp some 10mm with some heat shrink, in an enclosure, and then tails coming out of that through one compression gland into your 100 amp like fuse, 100 amp connector block. So obviously go into your connector block and then go into the other board, earth and neutrals, and then we can probably get away with, to be fair, from that enclosure again to the off-peak, so you'll have off-peak and on-peak fuse board. But my goodness, the nightmare house, crikey. So some dodgy guys been wiring that. I'm just thinking that's acceptable to leave it like that. Nothing with labels, so I had to use that little magic trick, so I just came up with that, just pink it on. It worked, thankfully. And yeah, it saved loads of time. If not, I'll be probably there trying to find out what does what. So yeah, then so that's all I've got time for today. But yeah, it's been great. Look at this property. It's beautiful. So yeah, if you enjoy this kind of content, then hit the like button, hit subscribe, hit the little bell notification so you know when we next upload. As always, have a good one from me, and I'll see you on the next one. Peace.